Okay, so today I am here with lecture 5 of chapter 3, right? Today we are going to study about resistor, okay? So, resistor, what is resistor, right? So, and resistor is a component of an electric circuit, right? Which have resistance, right? Resistor is a component of electric circuit which have some resistance, right? You know resistance, these things are already discussed in previous classes, right? So this is your resistance, right? So it is a component of electric circuit which have high or appreciable resistance, right? So just like your bulb, fan, right? These are the resistance, right? Okay, bulb, fan, washing machine, okay, fridge, okay, these are the resistance because these are the component of electric circuit and have appreciable resistance, right? Okay, but resistance, this is available in market, okay, available in market, or we are using for commercial purpose or some laboratory purpose, right? The resistor we are using in laboratory, okay, that resistor is mainly in two types, right? First one is wire wound resistance, right? And second one is carbon resistor, right? Okay, so this resistor is basically made up of lots of winding of a wire, right? Okay, and example of this one is manganese and nichrome, okay. So these are the resistor which is made up of lots of winding of Ly, okay. So this one is your wire bond resistance and another is carbon resistance, right? Okay, so carbon resistance is the nowadays we are using in electronic circuit, that resistance is very small, right? So even smaller than this one, right? So the nowadays the resistor we are using in our electronic circuit, just like your bulb, right? LED bulb, that is inside that bulb you are able to find carbon resistor, right? So mainly we are using this resistor in our electronic devices, okay. So that resistance is made up of carbon and made up of, that resistance is very small, right? That is resistance is very small, right? So it is difficult to write this resistance is having this much resistance. Actually that resistance is very small, right? If you are going to write something on that one, you have to write in very small letter, right? So it is difficult to write on, actual size is very small, right? If you are going to write resistance on that one, it is difficult to write, okay. But this resistor wire wound resistance is somehow in big size, right? So somehow big size means not this much, okay. That one is somehow like that, okay. So in that one we are able to write resistance. Suppose having 5 ohm resistance, we are able to write 5 ohm, right? But for this resistance, this is having very small in size, right? So it is difficult to write resistance on this one, right? We are not able to write on that one. So to find resistance of carbon resistor, we are using color code. We are using color code, right? So color code. So basically these resistor is painted with different colors, right? So with the help of that color, we are able to find resistance, right? So suppose this is your resistance, right? And this resistance is painted with different color, like that. So mainly painted with 4 color, right? Okay, 4 color is this one. 4 color represent 4 things, right? Okay, first 2 color will represent number, okay. Second color will represent multiplier. Last one is represent tolerance, okay. So to find resistance of carbon resistor, we have to remember this table, right? Because this table is useful to calculate resistance of a carbon resistor, okay. Resistance of a carbon resistor, okay. Resistance of a carbon resistor. So first you write all these things, and then I will try to explain how this table is useful to calculate resistance of carbon resistor. Okay, so just note it down. Okay, so you have written. So now I'm going to rub this part because I'm going to write something in this area. Okay, so as I told you, to find resistance of carbon resistor, right? To find resistance of carbon resistor, we have to use this table, right? Okay, so it is difficult to remember this table, right? So there is a trick to remember this table, right? If you know that trick, then you are able to write that table, this table. Okay, so what is trick? First I'm going to write the trick. Okay, so trick is BB Roy, BB Roy, Great Britain. Okay, so this is your trick to remember this table, right? So BB Roy, Great Britain, very good point, right? So here BB Roy. So this is your B for black, another B for brown, R for red, O for orange, Y for yellow, right? Similarly, we can write great, G for green, B for blue, V for very, right? Violet, and G for grey, and W for white. Right? So this, if you are able to remember this trick, then you are able to write this table, right? So first, in first column, we have to write the color, right? So with the help of, you are able to write the color, right? You have written up to this white, okay, up to white, and here no trick. Okay, you have to remember this one. Okay, so how? So most expensive is gold, na? Gold, and then silver, and then no color. Okay, so up to this you have this one, and in later part you will use gold, silver, and no color, right? Gold, silver, and no color. Okay, so number, first you write color in this one, and then you have to give number, right? So first one 0, 1, 2, 3, 4 up to 9. Okay, and then what is coming? Multiplier, right? So multiplier, just here number, just write here number and put power, this one on 10. Just write 10 and put power this one, right? So first one is 10 to the power 0, value will be 1. Similarly 10 to the power 1, here 1, so 10 to the power 1, here 2, 10 to the power 2, right? So you are able to write up to this, right? And here after that you have to go for negative, only for 2, okay? And then last one is tolerance, right? So for tolerance purpose we are using only 3 color, these 3 color, gold, silver, and no color. Okay, so for that one you have to run 5, 10, 20. Okay, so with the help of this one you are able to remember the table. Okay, so if you are able to remember this trick, then you are able to write the table, right? Okay, so once table is done, then we will use this table to solve, to find resistance of a carbon resistor, right? So now I am going to take a few examples and try to understand how we are able to how we are able to find resistance of a carbon resistor. Okay, so first example I'm going to take. Suppose this is your resistor, and this resistor is colored with 4 different, like this. Suppose this one is yellow, violet, brown. Okay, yellow, violet, this is your brown. Okay, and last one is gold. So this is your resistor, right? And this resistor is painted with 4 color, right? First one is yellow, violet, brown, and gold, right? So see, first two digit will represent number. First two digit will represent number, right? First two color will represent number, right? Third color will represent multiplier, and last color will represent tolerance. Last one will represent tolerance. Okay, last one will represent tolerance. Okay, so first two color will represent number, multiplier and tolerance, right? So see, so first color is yellow, right? First color is yellow. Yellow is how much value having? Yellow, this is your yellow. How much? 4, right? So here we will write 4, right? And second color will also representing number, right? And this is what? Violet. Violet is how? 7. So I will write here 7. Okay. And then multiplier, brown. Brown is, where is brown? This is your brown, right? And multiplier is how much? Multiplier is 10 to the power 1. We can write 10, okay? 10 to the power 1. And tolerance, what is tolerance? Is gold. Gold is having tolerance how much? 5, right? So here we can write tolerance is basically represented by plus minus 5%. Tolerance is given in percent, right? So that's why I am writing like this. Okay. So your resistance of this one, this conductor is okay. See tolerance. What is tolerance here? Now I am writing plus minus 5%, right? So sometimes now resistance is varying, right? Suppose temperature right now I am using resistor in here, right, in the 2B. Okay, so what will be the resistance? Here temperature is low compared to Delhi, right? So your temperature is low, you know, temperature is at low temperature, resistance will be smaller, right? At high temperature is low, resistance will be smaller. So here resistance will decrease, right? So we have to take minus sign, right? Okay, but if you are going to use that resistor in Delhi, right, their temperature is high, resistance will increase, so your resistance will change, right? That's why we are using plus minus 5%, because resistance is varying within these range, right, on the temperature. Okay, so I hope everything is clear to you, right? One more example I am going to take, and again we are going to understand how we are calculating resistance. Okay, so example 2. So again, see, this is your resistance. Sorry, this is your resistor, right? And this resistor is painted with again 4 pillars, right? 1, 2, 3, 4. Sorry, last one is silver. Okay, last one is silver. I'm taking any random color, and this one is your black, blue, and this is your red. So different color is given, and we are going to calculate resistance of resistor, right? So first one is black. Black is having how much value? Black is having in place of black, so of course we have to use another color, red. Okay, because black is having number 0. Okay, yeah, no problem, we are able to use black also, but I'm taking red. Okay, so red, where is red? This is your red. How much? 2. So first 2 digit will represent number. So first one is red, so number is 2. Second digit is blue. Blue is having how much value? Blue having 6. So second digit is 6. And multiply it again red. Okay, so red 10 to the power 2. So 10 to the power 2, right? And then tolerance we have to write plus minus, and tolerance I am taken silver. Silver is having how much tolerance? Okay, tolerance is having 10%. Okay, so this is your resistance of this resistor. Okay, so I hope with the help of this table you are able to type resistance of a carbon resistor, right? Okay, so to remember this table, you have to remember this trick, right? So this trick is very easy. Okay, so I hope this will help you. Okay, I hope everything is clear to you. So next I'm going to discuss electric power. Okay, next I'm going to discuss electric power. Okay, so next I'm going to discuss electrical energy and power. Okay, so electrical energy, or we can call it electrical energy. Okay, electrical energy or electrical energy and power. These things we are going to study. Okay, suppose this is your conductor. Suppose this is your conductor, and this conductor is connected to a battery. Okay, and battery is having potential V, right? Battery is having potential V. Now, so see, as I connected the battery, right? So current will start flowing in this one. Suppose I current is flowing in it, right? Now current is flowing. So see, you know, a battery. What is job of battery? Suppose if E volt potential of, if battery is having potential V, right? So suppose this is your battery, okay, and battery is having potential V, right? And you are connected battery across 2 points P and Q, right? So basically, if you connected battery across P and Q, this battery will create a potential difference of V across this one, right? So if you are going to connect battery at a point, right, across a point, right, and that battery is having potential V, right, that battery is having potential V, okay, so this battery will create across this one how much potential? Okay, so if across this point battery of potential V is connected, then this battery will create potential difference of V, right? V across this one. Suppose this one is having potential, this point is having potential V 0. So this side will be V, because only potential V is possible, right? But suppose in this side potential is minus 2V, right? Then what will be potential on this side, right? What I told you battery is creating potential drop across 2 points. If battery is having potential V, then potential difference across that point will be V. So if I am going to write like this, potential at P minus potential at Q is how much? V, because a battery of potential V is connected, right? And battery is creating what? Potential difference, right? Okay. This is how much? This is, we are going to calculate, right? And potential at this one is given, that is minus 2V, right? So this will come, Vp is equal to how much? This minus becomes plus, right? So V minus 2V, that is minus B. That means potential at this side is minus B, right? So battery is a device which creating potential drop across 2 points, right? If battery is having potential V, then potential drop across that point will be B, right? Okay. Okay. So now see, just you write it inside, okay? And now see, here battery is connected, right? And battery is having potential V, right? So this battery will create potential drop how much? V, right? So suppose in this direction potential is 0. In this direction how much potential will be? V, right? Now see, here potential will be how much? At this point, suppose here I am taking a point A, right? Here potential will be how much? Also V, because this is your connecting wire, right? And connecting wire is having connecting wire is having resistance 0, negligible resistance, right? Connecting wire is having negligible resistance, right? There will be no potential drop across this wire, right? Okay. Now, so this at this point potential is V, and this side is having potential 0. So at this point potential will be 0, right? Okay, and this is your B. Now you can see at potential at A is how much? V, right? And potential at B is 0, right? Now current is flowing in battery. How much current is flowing? I current is flowing A to B, right? Okay, so I current is flowing. So there is some charge is going from this side to that side. Okay, so because current is basically flow of charge, right? Now we can write let delta q is amount of charge flown in delta t time, right? So delta q will be equal to how much? I into delta t. Yes or no? Because you know the formula, I is equal to q by t. So q is equal to I into t. So amount of charge flown in delta t time is equal to I into t, right? And now, so how much charge is flowing? This much charge is flowing, right? Okay. So suppose I am going to calculate energy of this charge, right? Okay, energy of this charge. So energy, that means potential energy, right? So potential energy at A will be what? V into Q, right? You know potential energy is what? V into Q is your potential energy, right? Okay. So at this point potential is V, right? And charge is how much? Delta Q, right? Okay. So at this point potential energy of your charge is this much, right? But if I am going to calculate potential energy here at B, so again here also we have to write V into delta Q, right? And your V is 0. So 0 into delta Q value will be 0, right? As you see, at point A, charge potential energy of charge is how much? This much, right? But here potential energy becomes 0, right? Okay, so where is this energy is gone? Okay, where is this energy is gone? So this energy is basically went into form of heat, right? Form of heat, right? And that means your energy is dissipated in heat, right? And who is dissipating the heat? Conductor, right? And this, so due to this one, temperature of your conductor will increase, right? Okay. Now, so as current is flowing, conductor is consuming the electricity, consuming the energy. Yes or no? As current is flowing, conductor is consuming the energy, right? Okay. And every time he is consuming how much energy? This much energy, right? Okay. Then who is providing this energy? Battery, right? Battery is providing that energy, right? So as see you can see here, in this side energy is how much? In this side energy is how much? D delta Q, right? And this side becomes 0, right? So energy will come to this, charge will come to this side. Again battery will provide energy, right? And energy becomes this one. So battery is providing energy, right? And conductor is consuming the energy, right? Okay. And that consumed energy will increase, appear in form of heat, right? Okay. So I hope everything is clear to you, right? So we can write here energy of charge delta Q at A is equal to V into delta Q, right? Yes, and that delta Q is how much? I into delta Q, delta T, right? Energy of charge delta Q at A. Similarly, we can write energy of charge delta Q at B, at B. Okay, vector we can write like this, UA, right? And here energy at B is UB, right? And that UB is equal to V into delta Q, right? And B is 0 and delta Q, so value will be 0, right? Okay, yes or no? So this way we are able to write energy at B and energy at A, right? Okay, so next I am going to write energy dissipated, right? So energy dissipated, energy dissipated in conductor, energy dissipated in conductor, okay? Energy dissipated in conductor in delta T time is delta W, right? And this energy will be equal to loss of potential energy, inside the conductor, right? So we can write loss in potential energy, loss in potential energy, loss in potential energy in delta T time, right? So we can write like this. So delta W is equal to, right? Delta W is equal to loss in potential energy is how much? Initial energy was this much, right? And now becomes 0, right? So loss will be this amount, right? Bi delta T, right? Next, so you are calculated energy dissipated, right? Okay, so no doubt the next we are going to define power, right? So power is basically power is energy dissipated per second, right? So it is energy dissipated, it is energy dissipated per second. Suppose we are representing the power with P, right? So P is equal to what is? P is equal to energy dissipated per unit time. Per second is time, na? Per second, okay? Energy dissipated per second, okay? So per second, that means we have to divide with time, okay? So delta T, and W is having how much value? Bi delta T, right? Here also delta T cancel, so your formula of power dissipate, your power is how much coming? Power is coming Vi. So this is your power consumed by resistor, right? So if voltage is known to you, right, and current is known to you, you are able to calculate power, okay? So note it down. Okay, so this is your power, and this one we are able to write. So just you note it down, and some we are going to write power in different form, right? So you know power is equal to V into I, right? And your V is what? In Ohm's law you have studied V is equal to IR. Ohm's law, you know. Ohm's law, right? Ohm's law is V is equal to I, right? Okay, so here V I now, so in place of V we can write, IR, and one I is already here, right? So your formula is then I square R. So this is one formula to calculate power. Power is equal to I square R, right? Okay. And further we can write like this also. P is equal to what is V by I, right? P is equal to, sorry, V into I. Okay. So see, from this relation we can write I is equal to V by R, right? I is equal to V by R. So P is equal to I is how much? This much, right? So one V is already present, and in place of I we can write V by R. So V by R. So your formula is V square by R. So these two and that one, these are the formula which is useful to calculate power. Okay. So I hope everything is clear to you, right? In next class I will try to solve some question on electrical energy and power. Okay. So that's all for today.